Hello everyone, my name is Raina DeJute and welcome to my concepts video for Module 9. So this project is CodeBloggs. It's a full stack social blogging platform that I built using the MERN stack. And to be real with you, when I started this project, I thought the hardest part would be the code, getting React components to work, connecting the backend, making everything look clean. But honestly, the code was the predictable part. What I actually want to talk about today are 3 concepts that genuinely challenged me while building this. Not in a tutorial problem kind of way, but in a wait, this is what real development actually feels like kind of way. So the first concept is something you don't really see in bootcamp projects and not really something you can learn from a YouTube tutorial, and that's what it's actually like to collaborate with another developer. The second is about state management, specifically how I learned to think about where data lives and how it flows through a React app. And the third is about authentication architecture, understanding the full picture of how session-based auth actually works from front end to back end and back. So without further ado, let's get into it. So this was my first major project working closely with another developer. I built the entire front end and he built the entire back end. And on paper, that division of labor sounds really clean and really simple. I stay in my lane, they stay in theirs, we meet in the middle, and everything is fine. But what I learned really fast is that code is predictable and humans are not. So this is the first week where a completely uncontrollable variable was introduced into the equation. So it was not a problem of, oh, I don't know how to use this tech, let me look into it and figure it out. It wasn't a watch a YouTube tutorial or ask AI. It was really getting to test the limits of my communication skills, where I can communicate better, where I can seek to understand better, and how that communication skill integrates into a full stack development project. So for instance, let's take a look at this fetch call to API posts. This is where the front end asks the back end for blog posts. It seems very simple, but what you don't see here is the 3-hour saga where this endpoint kept sending me back data in a format that I wasn't expecting and it wasn't showing up. My partner was returning MongoDB object IDs as objects, sometimes as strings, and I kept getting bugs where my front end would either crash or it wasn't populating the posts because I was trying to compare 2 IDs that looked the same but weren't actually equal in JavaScript. So then came the idea for me to implement this normalized data utility. So this little function converts everything to strings so comparisons work consistently. It's like 30 lines of code, but represents hours of debugging, multiple Slack messages saying, hey, can you double check the format that you're sending back, and eventually just accepting that I needed to handle this on the front end. And that's the thing about collaboration, is that you learn that communication is not optional. It's not a soft skill, it's really part of engineering. Because when you're integrating 2 systems, the interface between them is just as important as the code on both the front end and the back end. We also hit a merge conflict. So I was working on the nav bar and they were working on authentication routes, and suddenly Git is yelling at us because we both touched this app.jsx. And at first I panicked a little bit. I thought I was going to delete their work or delete my work or break something very critical. But I learned. I learned to pull before I push. I learned to communicate what files I'm working in. I learned that merge conflict isn't a disaster. It's just Git's way of saying, hey, 2 people touched this, I need y'all to figure it out. And then there's a level of AI integration mixed into that. So at the beginning of the project, we create these AI spec files, and it defines everything that the AI is supposed to do and all of the rules they're supposed to follow when they implement a feature. Halfway through the project, I realized that the schemas that we were using weren't the correct ones. And so we changed the schemas in the back end and changed what the front end expects, but we didn't change the feature sheet. And so every single feature that was implemented afterwards, if it had heavy AI usage, was following the schema that was defined in the feature document, which meant all of the new features weren't working with all of the old features, and we couldn't figure out what was happening or why our AIs weren't listening to us. But that's the reality, is we're not building in a vacuum. We're building something that has to connect to someone else's work. And I feel like I was able to learn how to debug in a way that was actually very human because of a mistake that was human originated and AI implemented. But when it works and you hit that endpoint and that data flows cleanly from back end to front end, when the UI updates and when everything just starts clicking into place, it's such a rewarding feeling because we didn't just write code, we integrated with another human being's system. So that's concept number 1, is that collaboration isn't just about using Git or having meetings. It's about understanding that software development is like a multiplayer game. You have to communicate clearly, adapt to other people's decisions, and accept that sometimes the right way to do something is just the way that makes both systems work together, not the way that I would have done it if I was working on it by myself, and not the way that he would have done it if he was working on it by himself. So our second concept is state management and data flow. This is where I really started to understand React, not just how to use it, but how to think inside of it. So when I started building the homepage, I knew I needed to display posts and comments, which seems easy, right? We just fetch the posts and we fetch the comments. But then you start asking questions like, where does this data live? Does each post component store its own data? Does the parent page store everything? What happens when a user likes a post? Who updates that? What about when someone adds a comment? And this is where I had to learn to think about state ownership. So I ended up keeping posts and comments in the parent component, the homepage, not in each individual blog post item, and the reason is control. So if we take a look at this handle like function, when a user clicks the like button, I need to update the like count, but the like button component doesn't own the post data, the homepage does. So the like button receives a callback function as a prop, which is on click, which it calls when it's clicked. The callback runs in the parent, updates the posts array, and then React re-renders everything that depends on that data. So this is what's called lifting state up, and it clicked for me when I realized that the component that needs to update multiple things is the component that should own the state. But here is where it got interesting. What if you need to update state across completely different parts of the app? And that's why we find ourselves in postmodal.jsx. So when someone creates a new post inside of the post modal, the modal doesn't have access to the home page's state because they're not parent and child. They're siblings inside of a main layout. So if we take a look at the actual UI, we can see this post right here. When we click on it, the post modal is what pops up right there. So for this, we used a custom event system. So when the modal successfully creates a post, it dispatches a post refresh event to the window object. And if we go over to home.jsx, we can see where we're listening for that event, which is right here, the window add event listener post refresh. Now in a bigger app, I might use Redux for this or Context API, but for this project, custom events were perfect. It's simple, it's explicit, and most importantly, it works. But I did use Redux for a global alert system because alerts need to be triggered from anywhere in the app and displayed in a fixed position on the bottom of the screen. That's a perfect use case for Redux. But I didn't put posts or comments or user data in Redux because those are page specific. The homepage doesn't need to know about the network page data. Keeping local state makes the app easier to reason about. So here's the data flow for a post modal. So the user types in here, we'll put testing. The user submits the form. The modal sends a post request to the backend. The backend creates the post, sends back a success message. The modal dispatches post refresh event. The homepage listener catches the event. The homepage fetches the fresh data, and then React renders with a new post. So that's 7 steps in total, and every step matters because if you mess up the state flow, which I did, if you try to update state that you don't own or forget to trigger a re-render or don't clean up event listeners, you get bugs. Silent bugs, the kinds where the UI looks fine, but the data is stale. And in this app is also where I learned about optimistic updates. So when I click the like button, I don't wait for the backend to respond. I update the UI immediately, send the request in the background, and we only revert back if it fails. This is what makes the app feel instant because state management isn't just about correctness, it's about user experience. If every button click requires waiting for a server response, your app just feels slow. But if you manage state well, you can make interactions feel instantaneous while the network request happens behind the scenes. So that's all I've got for concept number 2. State management is about asking who owns this data, who needs to update it, who needs to read it, and how do those pieces all communicate with each other. Once you understand that, React stops feeling like magic and starts feeling like a tool that you can actually control and use. So if we move on to concept number 3, which is session-based architecture and authentication. So if we go to login.jsx, this one took me a while to fully understand because authentication isn't just a feature, it's a system, and it's a system that touches every layer of the application, both front end and back end. In the past, whenever I had to implement any sort of authentication middleware, whether it be session tokens or authorization headers, I always understood it as a back end concept. And I didn't realize that the front end also plays a part in that too. So on the login page, the user enters an email and they enter a password. Then they hit the form submit. I send a post request to the backend, which is here. Then the backend validates those credentials against the database. If they're correct, it creates a session record in MongoDB, generates a session token, and it sends that token back to the front end in an HTTP only cookie. So if we look in our dev tools, we should be able to see that cookie right here, the session token. So this session is not something that you can access from JavaScript, which is a security feature. It prevents any sort of attacks that can steal your token. So when the login succeeds, we don't store the session in local storage. We don't put it in the React state. The browser just handles it automatically. Every request that I make to the backend from that point forward includes this session token cookie. But then here is where it starts to get more architectural. If we go to app.jsx, when the app first loads, before any routes render, I need to check if the user has a valid session. So this runs on mount. It sends a GET request to API session validate. The cookie automatically is included because I'm using this credentials include in the fetch call. The backend reads the cookie, checks if that session exists in the database, and if it's still valid, then it sends back the user's data. And then we set the authentication to set is authenticated true, and then we populate the current user with the user's ID and data. Now, here's why this matters. All of my protected routes depend on this state. So if we scroll down, we can see the render protected function. This function wraps every protected route. It checks if the user is authenticated. If yes, render the page in this main layout. If no, then we redirect to login. So authentication is a gatekeeper. You can't see the home page, blogs page, network page, or admin page without being authenticated. And this check happens at the route level, which means it's enforced consistently across the entire app. And then if we log out, I can show you what happens. We see the session token lives here. When I hit log out, it's cleared. And then if we take a look at header.jsx, which is the component that logout button lives in, we see this handle logout. So what's happening is I send a post request to API session logout. The backend deletes the session from the database. Then I clear the cookie on the front end, set is authenticated to false, then we clear the current user and navigate back to the login page. And this is the full circle. Authentication state controls what you can see, but it's not just front-end tricks. The backend validates every request, and if you try to access a protected API endpoint without a valid session, then the backend rejects it. So now let's talk about how authentication state flows through the app. So if we take a look at main layout.jsx, we see this current user prop being passed. The authenticated user object starts in app.jsx, then it gets passed to main layout. Main layout passes it to header and navbar. Header uses it to display the user's name and initials. Navbar uses it to conditionally show the admin link if you're an admin. This is what's called prop drilling, and normally prop drilling is considered bad practice. You're passing props through components that don't use them just to get them to the components that do. But in this case, it works because the component tree is shallow. It's only 3 levels deep, and it makes the data flow explicit. I can see exactly where the user is coming from. And there's also an admin check. So if we go on the page, right now I'm currently an admin user, as we can see. When I hit admin, it takes me to this admin page. If I were to log out and log in as a non-admin, if I try to put admin here and then hit enter, it takes us to the home page. So even if you're authenticated, but your role is an admin, the page redirects you to the home page. So it's a 2-layer protection. Authentication at the route level, authorization at the page level. And this taught me something else really important, is that front-end protection is about user experience, not security. So if I really wanted to, I could remove these checks from the code, recompile, and access the admin page UI, but I still couldn't call the admin endpoints because the backend would still reject me. Every single API call that I make includes the credentials include. So this tells the browser, send cookies with this request, and that's how the backend knows who I am. And this architecture, session-based auth with HTTP-only cookies, is more secure than local storage tokens because even if someone injects malicious JavaScript into the page, they can't steal the session token because the browser protects it. So those are the 3 concepts that genuinely challenged me while building CodeBloggs. Collaboration taught me that the software development is a team sport. You have to communicate, adapt, and integrate your work with other people's systems. State management taught me to think about data ownership and flow. Where does state live? Who updates it? And how does it propagate through the app? And authentication architecture taught me to see the full system, from front end to back end to cookies to validation and back. These aren't the kind of concepts that you can find in a YouTube tutorial or ask AI to explain it to you. They're the concepts that you hit when you're actually building something real and something that has to work across multiple developers, multiple pages, and multiple layers. And honestly, that was the best part of this project. Not that I built something that works, though that's cool, but that I ran into real problems and had to solve them without a tutorial telling me the answer. That's where I believe the most growth happens, not in just following along, but in figuring it out. So that's all I have for this video. Thank you for watching, and I will see you on the next one.